All right, folks, it's me again, and it's time to move a little bit farther along with our discussion of the motion of things. Last time we talked about this, we talked mainly about speed and said speed and velocity, who cares? It's just something going down the road. And now that's going to change. And this lab is a very instructive sort of lab. You're going to be figuring out some things sort of on your own, but also get some experience working with things working with the stuff we've just been talking about with words so far. So I have a lot of things I want to help you get started with. So I'm going to jump through the lab and show you various things. And then when you work on it over the next, I guess it'll take a couple of days, then you'll go through all the details and figure it all out. And you'll upload your answers to WebAssign, and I'll grade them when you're finished. So let's go ahead and get going with this. This is the WebAssign site that you've run into before. And I'm going to log in. That's a funny looking username. Okay, and let's see if that works. Okay, I don't want to update that password. Now, incidentally, you all have a different, of course, username and password. And the username and password that you use are the original username and password you were given at the beginning of the course, not after you've changed it, what it was at the very beginning. If you have a problem with that, if it didn't work for some reason, just let me know and we'll wrangle it. It's very easy for me to fix any kind of problems. Okay, the lab we're looking at here is the velocity lab, and so I'm going to click on that right there. And that's pretty exciting. I have all this stuff right here. But what you should also have in your hands is this version of the lab, and that is the print copy, the PDF version of it. And this is what you're going to use as instructions to guide you through what's going on over here. Okay, so let's see. I'm trying to think of, I guess there's nothing else with WebAssign besides just getting here. And one of the first things you're going to need to do is get the Dynamics track and the Grapher program up and running. And this is set up. Notice I have one tab up here. If I click on the Grapher, it'll pop the graphing program up. And if I go back to WebAssign and click the Dynamics track, I'll get it there. So there we have them, all three right in a row. And so you can kind of jump back and forth among these things as needed. Okay, now by the way, this kind of looks like the lab down here, but that's just actually a picture of it. What we're going to be using is the real thing here. And as you recall, we did this business with having this track that, with a card on it that moves around like so. And we did a little bit of stuff with this sensor, although we didn't do anything all wiggly like that. And we're not going to do anything wiggly like that today. So I'm going to click Set Angle to 0. And we're going to just be looking at things moving at constant velocities or constant speeds in various directions back and forth across the track. I'm going to clear that line. And the first thing that you're asked to do is to kind of get an idea of how this graph here, which is notice position versus time, corresponds to what's up here. You can turn on the ruler like so. It turns off and on with that button. You can drag it up and down. And the best place to have it, if you're going to use it at all, is up here, because the mast's location is is the cart's location. It's like the center of mass of the cart. And one thing that you're asked to do is to find out about the extremes and the midpoint. Well, if I move this over to 100 and turn on the sensor, notice they get a nice horizontal line at 1 meter. And it's horizontal because the position is the same at all times. Likewise, if we go to this extreme, we get that down there. And this extreme, we get down there. I mean, up there at the top. So there's the range. It doesn't quite get to 0 or to 2. Now, you're also supposed to find out what the minimum value is. And notice that when I have it all the way to the left and I turn on the sensor, the smallest number we get is 0.075 meters. And that's one of the things you're supposed to enter in WebAssign. And that's not WebAssign. Here's WebAssign. And so, for example, it asks you X minimum. You would type in that 0.075, and you definitely, it says enter. Oh, it has units afterwards. Usually the units aren't there, or often the units are not there. and you have to include them. The meters are out there. Now remember I told you about submitting. I'm going to scroll right to the bottom of the page and click Submit Answer. And why not save? Well, actually, for some reason the save's not there. I'm going to go back up the top, and notice now it says that my value is acceptable. It isn't perfect, I guess, but anyway, it's acceptable. And so that's the way it works. Now, remember the bit about 10 submissions. You might think, why did I go ahead and waste one there? Unless I change this, I'll never use another submission for this one right here. So you get 10 for each answer. And I know that's redundant, but I want to make sure that you don't get in a panic over that. Okay, now let's move on down here to some other stuff. On the second page, and by the way, there's a space here for you to write that number in here. It's really important that you keep track of all this stuff on your paper. For one thing, this WebAssign thing just goes away. I mean, you know, at the end of the course, whether it's gone, and if you want to show your college professor or whatever, and some of you will be asked to do that. If you try to bypass the first year of a course or something, they'll say, what'd you do in the lab? You can say, here's the stuff I did. But also, the WebAssign site doesn't have all the textual stuff to explain what the whole thing's about. The printed copy has the whole story, including the data. WebAssign just has the data. So you definitely want to make sure you fill in all the stuff on our sheets here. All right, now moving along, let's see, what else do we have here? It talks about the ruler, the original velocity I just talked about. There's the sketch tools business, but I think I'm going to skip that for the time being because I think we're in pretty good shape with that for the time being. And then we get down to the next page here. Okay. No, is that? What the hell? Yeah, there we go. My page is just laid out different. Okay. So now we have one of the first things you're trying to do here is you're trying to create a shape on the graph. And the purpose of this is to get you familiar with the motion and the graph, and so that you can look at the motion and imagine the graph, or look at the graph and imagine the motion. And that really does turn out to be useful. So one of the things you're supposed to do here is create this M shape. And I'm not going to do that one for you because it's kind of funny. You'll find it much more difficult than you might think. But you're trying to make a shape like an M. I'm going to go ahead up here and see with my apparatus and see if I can make maybe a V. Suppose I wanted to make a V. How would I make a V? A V starts up here, goes down here, goes up there. So what does that mean? If I want to start up here, this is at the beginning, at a low time, I want the cart at a high position, and that means it's over here. And by the way, if you change the match graphs to 1, then the little dot's there, and that helps out. Okay, so I want to start there. I want to be here halfway through the motion, and then I want to be up here at the end of the motion. So I want to be right here in the middle, over here at the end. So, and back up here at the end. So let me backtrack. I want to be here at a large magnitude, all the way over here to 0 in the middle, and all the way back over here at the end. See, I'm learning myself. Okay, now to draw the graph, I click on the sensor, and then I start moving. So I'm going to go across here like so, and back up here. Boy, that's ugly. And one thing I find out is that it's kind of hard to do. Another thing I found out, it's kind of hard to do that quickly, and you can change the time interval here so that you have more time to do it. So let me try it again, see if I can do better. I'm going to go, make it a V. What does making that a straight line for my V mean? It means a constant velocity. And going back over here like so. Okay. All right, so that's not too bad. So you get the basic point here. You're trying to think position on the graph, shape of the graph, where you start, where you end up, steep or shallow. It's amazing how you're learning out there. Okay, it's actually me that's learning. You'll get your turn here in a minute. Okay, now let's zip here to the the documentation here and look at something on this next page on the procedure, because we were mainly just exploring things. Okay, it says, is the entire graph significant? Okay, what the heck am I talking about here? Well, suppose that you were doing a thing where you were supposed to look at something that it has a graph that looks just like this, a rising straight line. Well, you start the timer. As a matter of fact, let's just make that happen. I'm going to bring it back over here, and I want to have a rising straight line. I'm going to change the speed to say 60. Now, I want it to be a straight line that rises, so I want to go up like so. So early on, it's at the left. Later on, it's at the right. And so I'm going to start the sensor because I have to do that. And then I'm going to click go. Okay, and that's steeper maybe than what I was supposed to get. But that's the point I'm trying to get at here. If you were then writing down the graph that you got, and the graph was supposed to be of this thing going at a constant speed to the right, this little segment here and this segment over here are not important. They're not a part of your data. Okay, those were before and after the experiment. And so that's what I'm talking about here. People get all bent out of shape because they think, what about including that in my data? Shouldn't I include all the data? No, because that wasn't a part of what you were trying to do. In this case, you had something that's going at a constant velocity, and a constant velocity to the right. So it's just the straight line. So I hope you get the picture there. Something else down here at the bottom. This is the first time I ask you to answer a question. What's similar about these two graphs right here? Not the motions, the shapes of the graphs. This is a biggie right here. This is one of the places where I get people asking, writing and asking questions here, because what they do is when it says what's similar about the graphs, they'll say things like both cars were going to the right, but one was going faster. That is completely wrong, because that has nothing to do with the question. The question says what about the graphs? Well, what is similar about these two graphs? Okay, what's similar? Well, they're rising. They're also straight, and I have both are straight lines. And notice I have free answer just to get you started here. So what is similar about them is they're both straight lines. The fact that they have different slopes is what's different about them. It says what's different about the two graphs? This one is steeper than that one. Notice I didn't say anything about the motions. What does the slope of a position time graph indicate about the motion of the cart? And how are you supposed to know that? Based on your answers to the two previous questions here, these things both have certain velocities, certain constant velocity. This one's steeper, and when you did this part of the lab, you made the cart go faster. Another thing is they both rise by the same amount, both the same change in position, but this one took less time to do it, so this one's going faster. You get the point? These are the kinds of questions you'll be asked in the lab here. Okay, and there are a couple of free ones. And now let me see what happens on page 5 here. Okay, another little notice down here that you no longer have any drawings on the graphs, because those were just practice ones there. And what we're doing here now is to launch the cart at -20. We have and the second thing is repeat with another trial at -50. So I think you can kind of see you're doing the same thing as on the previous page. In this case, it's 20 centimeters per second. This one's 50 centimeters per second, probably. Yeah, that's what it is. Here it's -50, and then there's -20, and then -50. And you're going to go ahead and do that. But something else that I point out here somewhere, I think it's up at the very top somewhere. I've forgotten where I wrote this. You need to draw all these graphs. Okay, remember I said before that by using this printed out copy, you're able to have a record of what happened in the lab. You're going to be uploading images of these labs to WebAssign, but when WebAssign has them, it doesn't mean you have them. And so what you want to do is write these things so you'll have them when you're trying to look at the lab, study for a test, and all that kind of business. Okay, so back we go. What's going to be similar? Well, I think you'll be able to figure that out when you do that part of the lab. So you have your pictures there, and you'll answer very similar questions about it. and you'll also compare part A to point B. This is part B, and you'll compare it to what happened in the previous part. And I think you can imagine it might have something to do with directions and that sort of stuff. Okay, what else we have going on here? Now, notice it says a very strange instruction you've never had in a lab before. Please step away from the cart. The label on the next graph is prediction. And this is yet another thing that I want to rant about. Here's prediction and observation. Those previous pairs of graphs were this case and that case, but here we want to make a prediction. Why do we want to make a prediction? We want to make a prediction to help you fix this stuff in your minds, okay? If you look at it and draw it, not much thought took place. So you're supposed to say, here are my orders. What does it say here? Set the recoil to 0.3 and the original velocity to 50. So here are the instructions. The recoil, we learned last time, has to do with how quickly it bounces back, and the velocity is 50. And so I ask you not only to do that stuff, but I say you're going to start with the thing at about 0.1 meters at t equals 0 and let it sit there till 2. And then I tell you to draw that. And so you're supposed to draw that down here. And then I tell you to, actually draw the 2 points, and then launch the cart, and then draw that part of it, and etc. So there are various steps here, but the important thing here is that I tell you that you're supposed to predict what happens, draw your graph, and then actually do the same thing, and then create. And then I think maybe you upload this graph, but you'll actually show the results of your observations as well as your predictions. Okay, so that's what's going on there. And at the very bottom here, it says to sketch. Click sketch in the dynamics track. Let me show you what we're talking about here. Let me just suppose that I was asking you to reproduce this graph and upload it. And here's how you can do that with Sketch. It does this really weird thing where it overlays the lab with this thing. And if I wanted you to reproduce this down here as a sketch and upload it, well, you've got to move the axis down here. You've got to change these labels to time seconds. And you got to change this to time seconds, change this to position in meters. And then you need to get this little straight piece. Well, one thing you can do is put a dot like right around here and another dot there, and then connect them. You don't necessarily have to have those dots because these little lines come with dots, and there weren't any dots anyway. And then likewise, right up here somewhere is where you want to go from before. You can bring a line over here, and etc. Okay? And so, and incidentally, normally this first stretch here wouldn't matter because, as I showed you before, those are not important. Now, if you exit Sketch, that stuff doesn't go away. Yeah, there's a clear sketch, but anyway. Now, one thing that you might be asked to do, and so let me look and see if WebAssign asks you to do that. Let me see if that's in here. Let me find a place. Well, I was thinking that it might be here somewhere. But anyway, so we'll probably run into that again in a moment. But let me just show you an example here. If you needed to make a copy of this graph, you click on the little camera as we've seen before. You drag across it like so. And when you release the button, a requester comes up that lets you save it with an image. And incidentally, some of these things, and I think these require you add that. Yeah, when you do it in the apparatus here, you have to be sure and put .png at the end, and then when you save it, you'll have it, and then you can upload it to WebAssign possibly later on. All right, so that's that business there. And now let's see what's going on page 7. More of the same sort of stuff. was hoping we would run into one to upload here in a minute. Yeah, the next couple, as a matter of fact, let me just show you these. The next couple of pages here, once you've done this, we get into an interpreting the graph business here. And so what you're asked to do is put in words what this graph is describing. And I think later on the reverse happens. You get the words and you're told to draw the graph. So that goes on for a couple of pages. And then what happens is, we've been just talking about this position and displacement here. Then we come to velocity. And what we're going to find is that we can take information that we found in the first part of the lab with position versus time, and we can get velocity information from it. And let me see. Let me just see where. I'm trying to find a good place to have a look at it. I'll tell you what I'll do. I'll just do something bogus here. Let me clear all this stuff, and I'm going to leave the original velocity at 60, and let's say this is 0.3, and I'm going to start the sensor. I'm going to click go, and it's bouncing back more slowly, and you'll be doing something very similar to this when you do the lab. And I might even be instructed, and by the way, this 20 seconds is longer than you'll generally use in the lab. Okay, suppose this was a part of the lab you're supposed to be working with. Now, what we want to do now is see if we can find where velocity is shown in this picture. This is position versus time. Well, remember that velocity is change in position per time. Well, this height here is the change in position between this time here and this time down here. So that is the slope of this. The rise is a change in position over the run, the change in time is the velocity. So we should have a big velocity here. Now, here is the fall here is the change in position over this longer time here. So two things happen. It looks like that this slope is less. This isn't as steep. What does that mean? Well, notice it has the same displacement this way, except that way, except one's negative. So it has the same distance it travels, but a greater time. So what do we expect we have for this one and this one? If you were to put in words what's different about what this line says and this line says, this one is going faster and it's going in the positive direction. This one's going slower and in the negative direction. And the graph says that to me. I don't know if it says that to you, but hopefully it does. Well, let's just copy this to the clipboard. And now we're going to go to the Grapher program, and we're going to paste it in there. I hope. Okay, there's our graph, and it looks just like it did before. And as a matter of fact, we learned last time to talk about finding the slopes of these graphs, say the slope between here and here, by drawing the line of best fit between these 2 points. And that tells us the slope is 0.6. Does that ring a bell? What does that have to do with? 0.6 meters per second. Over here, if we draw across this graph, what are we going to get when I release it? What's it going to say down there for the slope? Minus 1.8. What the heck is that? What did I use for my... Oh, let's see. I used 0.3. So 0.3. Oh yeah, 0.3 times 60 is what we expect to get that. Oh, this is 0.18. That's meters per second, and the other graph is in centimeters. So we get a 18 centimeters per second graph here and a 60 centimeters per second graph right there. Okay. Now, what would happen if we were to plot the slope of this graph versus time? Okay? Remember, we don't care about this little bit down here. We don't care about this. What's the slope of this part right here? It's 60. What's the slope of this part right here? It's minus 18. And it's 60 for this entire time here, and it's minus 18 for this entire time here. Picture that graph in your minds. Think about what that graph would look like if we plotted velocity versus time, not position versus time. Well, hopefully what your mind is coming up with is this graph down here, and I'm going to turn off the linear fit. Here is the constant 60, and this is centimeters per second, and here is the constant somewhere around minus 20. And as a matter of fact, there's a little examine tool. I'll see that it says, if you'll look at the examine tool, that right-hand number is minus 0.178. That little minus 20 actually, this little minus 20 actually goes with the bottom of the grid right there. So here we have everywhere is around 60 centimeters per second. Here it's all down around minus 18 centimeters per second. Okay, you got the plan? I hope that makes sense to you. So that's what happens in the second part of the lab. In the second part, you're going, I have this position versus time. Since I know the slope is the velocity, I have velocity versus time, at least in this simple case. Now, when we start to rock the track around a little bit, it's going to get a little bit wonky, but we'll see that soon. Now, there's one last thing here. If this position versus time graph contains the velocity versus time graph, would it be possible that the reverse might be true? Well, think about this velocity versus time graph right here. Yeah, this is the velocity versus time graph. If I start from this instant here at the top and start going across here, notice it moves through a negative distance. Okay? What's going on down here? It's moving at a negative velocity, which means it will make it go a negative distance. Now, here's this constant velocity. Here is this constantly changing distance right here. How are they related? Well, let me just show you something. By the way, for you people who've had calculus, you recognize a lot of this. The slope of this line is the magnitude of this line. Okay, what about this graph down here? What about if I drag across here and let go? Okay, and I'm going to do integrate. Okay, this area down here has an integral of minus 1.82 or minus 100. Let's see. Yeah, I'm trying to think why that's 182. That's supposed to be, yeah, I guess that makes sense. That's the display. Well, looks like it's off kind of a bit. The area under here should be equal to the change in height of this up here, which doesn't seem right to me. Well, I apologize. I'll have to examine that. Oh, I'll tell you what, I'm looking at the wrong. Yes. Here's this graph's area. Here's this graph's area. That's more better. All right, the area under here is this number right there, 0.39. 0.39 is how far this thing went backwards. Right, okay. Here's the area of this one. That just does not compute. Oh, I think it's getting me the, I'm sorry, what they was doing, it's doing the entire distance. Let's try that again. Okay, that's better. Okay, it was getting the entire area of everything. The area under this is the constant velocity times the time, which is the height of this box here. The product of those two is the displacement, and it has a negative area, and this has a negative displacement. Okay, that's a whole bunch of stuff. And I know that it's like, ugh, particularly at the last, it got pretty wonky there. And this lab kind of gets wonky at the end for you too. And you're going to be doing something very similar to what I was just doing. So I hope this kind of giving you a trip through this thing before you have to do it on your own is useful to you. I believe when we do the acceleration one, we won't need as much of this sort of an introduction because you'll be a little bit more familiar with the tools. But we have looked at displacement and velocity, how they're related in both directions, okay? So hopefully you're ready for the lab and it's time to get on with it. Enter your answers. Remember to submit and save frequently, and it'll grade the parts that can be automatically graded, and the rest I have to grade. Whenever you need to have your labs graded that are in WebAssign, you need to let me know. Send me a message, say, I think I'm done with this. Please grade the velocity lab. I'll get your message, I'll grade it, and I'll insert comments, and if there's a fair amount that needs to be changed, I'll get back with you and say, I've graded it. If you'd like to give it another chance to fix it, then you can do that. So that's what's ahead. Good luck with that, and we'll see you next time.